Hello, and welcome back to the final session of day one at CES with BrainChip's All Things AI podcast. We're here with a familiar face, Jim McGregor, founder, CEO, and principal analyst at Tirias Research.
Speaking of familiarity, you've been at CES a very long time for quite a few sessions. What is different about this CES?
First off, I think it's the first CES since COVID, and where I think we're seeing normalcy. So we've got people here, more people from Europe, more people from Asia. We're not seeing kind of the limit that we had over the past couple of years. So that's one thing. And that's bringing with it, I think, kind of that breadth of innovation. CES really isn't just a consumer electronics show anymore. It's really an electronics innovation show. Everyone comes here for automotive, for health tech, for fintech, for pretty much everything to show off the latest and greatest technology. And I think we've returned to that. And some of the technology I've seen so far is pretty phenomenal.
Well, speaking of which, right, we've had a couple of discussions already. And is there anything you see at the show that says no AI?
No, if I was going to say the key themes of this show, or at least the major themes that that's really stepping out in my mind, are AI and Gen AI, and especially the latter of how we're converting to Gen AI and how we're going to use Gen AI. AI PCs obviously have become a big issue over the past 6 months with Intel and Microsoft announcements. XR. A lot of interest in XR, a lot of new technologies coming out to improve the whole virtual or extended reality environment. And then the other one would be automotive, transportation. And transportation is, first off, it's always been interesting. We've had EVs and AVs, but now there's a growing interest in hydrogen solutions. And it's not just about cars, the consumer cars. It's about major transportation for marine, for ships, and for trucking, for trains, for micromobility. Whether it's a scooter, whether it's a bicycle, whether it's whatever. So transportation as a whole continues to grow as part of CES.
And what you see on this, right, is clearly there's a lot going on towards alternate energy sources, right? And products that support that. Clearly, transportation is a growing problem because it's constantly growing. But what do you see as trends from a technology standpoint that are being addressed and demonstrated at CES this time?
It's funny because, we've had a lot of this technology for the past decade. AI's been around now for a number of years. We've been able to do deep learning as well as neural network processing. We've had a lot of capabilities in terms of, communications, in terms of sensor technologies, but I don't think we've kind of completely put that together. And now we're seeing those come together. In fact, I would say if there's an unsung hero at the show, it's sensors. Going through CES Unveiled or PepCon last night, 99% of the products there wouldn't exist. Not just because of processing or communications or AI, but they wouldn't exist without sensor technology, especially. All these consumer applications, even if you have the neural network model, you have to be able to accurately sense information about the person, about the environment, about the technology. And I think that is kind of the key piece where we're learning how to use the sensors and use the data from those sensors to create really intelligent solutions.
I think this is a great segue into my favorite topic, which is how getting intelligence close to the sensor. Right? And a couple of things you mentioned at the beginning about AI, but Gen AI, I believe is putting a lot of pressure on the data center and on the cloud. Whereas moving some of that intelligence closer to the sensor will probably help, because one thing's not changing. We are going towards more intuitive human-machine interfaces, right? That is going to be a lot more understanding of sensing, whether it's audio, voice, visual, touch, etc. And with everything that goes around it, and especially with generative AI taking that input and pushing it back, that would put the compute load at the cloud over the top.
Oh, absolutely. Matter of fact, we actually, as Tirias Research, did a study. We did a forecast for generative AI. And right now, where we are with generative AI is kind of like, I like to tell people it's a 2G smartphone. We didn't have video capabilities. We didn't have broadband connectivity. We didn't have social networking applications. So it was basically just a dumb communication device. Once we did that, the amount of data that we were creating and sending to the cloud just exploded. And we're there with AI. We're doing text to speech, text to image, simple things like that. Over the next 24 months, we're going to see more of that transition to video and to consumer applications and all this. And that's going to explode. So we did a forecast for all this for Gen AI growth, according to different users and different applications. We also did analysis on what this does to data centers and what the data centers are required. And this whole TCO, total cost of ownership or total cost of operation analysis, is mind-numbing. We came up with numbers that were somewhere initially $72 billion in the next 5 years. Now it's up to $85 billion over the next 5 years. And that's not including the brand new data centers that have to be built to support this, especially for the training. You're talking about super data centers, or what Jensen Huang likes to call the AI factories. These are going to be data centers packed with GPUs or some type of high performance accelerator or liquid cooling, all this stuff. It's kind of a data center on steroids, if you will. And it's huge. It's just huge. So I think that there's two major trends now that go hand in hand with building these large language models. One is, we need to shrink these models, make them more specialized for specific applications and smaller. And two, we need to move them to the edge. And everyone's talking about that, but we're just now trying to figure out how to do that. And there's not just the thing of offloading the data center, but you have improved security, improved performance, lower latency, all these, and not to mention increased data security and really that true environmental solution, where you've got sensors and generative AI that can sense the cognitive sensation about the environment and the person or the application that's being used for. And that's really a huge need to make these intelligent things, to be able to use these sensors, to be able to use these models, and to be able to do it in an effective way. Because quite honestly, nobody today has a business model to make money doing Gen AI in the cloud, especially with the cost of those cloud services.
That's well put, right? And finally, what is the use case that starts making this happen? How do you actually make it cost effective to do that as you move it to the edge? Clearly, this, as you say, is not just a hardware problem. It's not just. It's going to be models. It's going to be storage. It's going to be a solution that is partitioned the right way, so you do the right things at the right places. Because clearly, there are going to be heavy compute areas. There are going to be lighter compute areas that you need to kind of go through. So, what do you see at the show that gives you hope that you will start seeing that move to the edge? Anything that strikes a fancy?
Well, it's going to sound kind of funny, but it's the sensors. I'm seeing innovative sensor applications. One company called Naki Logics has earbuds with several different types of sensors, electrical sensors and INU, and I can't remember what the third one is, but they actually can sense electrical charges through your head. So like if you flex your jaw or something like that, as well as movement, slight movements, not jerky movements, where they can actually control things. It makes a great user interface where you don't need a voice, you don't need touch. Some of the examples they showed were the founder actually did a 737 flight demo with just the earbud control. He also had one of his friends that's a quadriplegic be able to do things like typing and user interface on a computer very effectively. I think he could type faster than I can. That scares me. But yeah, and it's non-invasive, so it's not like embedding a chip in somebody. Another one was a company called Afferents, and they're actually putting kind of like rings on your fingers and actually kind of creating a link or a sense to your actual nerves in your fingers. So you still have full use of your fingers. You can pick up and do things and touch things with your fingers. But when you're in the virtual environment, it kind of trains your body to have that sensation. So like you're pushing a virtual button, or you're feeling something that's not physically there, or even the weight difference between different objects. It's phenomenal. And I think this sensor technology is really going to fuel a big part of this, because we can do so much more than we ever could before. Matter of fact, once again, I don't think majority of these products wouldn't exist without that sensor technology. And that sensor technology requires this level of AI processing and enables it more than anything, enables that type of intelligence.
And I think it's a kind of virtuous circle at that point, right? Which is, hey, there's sensors that can do really, really interesting stuff. There are models that are beginning to understand it, but then now you need the third part, which is the compute that makes all of that happen while not compromising form factors, battery life, and usage cases, right? And so this effectively you're talking about are not just non-invasive from an entry perspective, but shouldn't be cumbersome to actually hold on your person.
Yeah. And when we talk about applications like security or healthcare or wellness, some of these things that really require low latency, high performance, you need to have that. And you don't want to have that extra network connection. You have the data security as well, but that network connection can become a hindrance. You really want to be able to do that processing on the device, on the edge, be able to do it effectively.
Right. And that's, again, music to BrainChip's ears, right? That all the things that we've been talking about for a while seem to be slowly getting there, and probably speeding up, about how do you actually do extremely efficient on-edge compute, and more importantly, things that can be personalized and learn on device rather than having to go to cloud. And in fact, as I kind of look at it, the sensor technology is moving forward. We're doing more efficient work on the compute itself, and then we have to have a way for it to learn on device. If we do that, all these sensors which do not have vetted kind of deep data sets, you need to start making good with the amount of data you have, right? And so the ability to learn from lesser data, because there is so many diverse environments where these sensors operate, you can't just have a standard data set. It needs to be constantly evolving, and there needs to be chips and devices that can adjust to that in real time, so to speak, as it evolves.
And definitely you have to have that capability of expanding that model over time. So you have to have a growth path, because this data isn't going to stay static. It's going to continue to grow. The number of sensors, the way we use sensors, and the amount of data that goes into this is going to eventually grow this, but it's also going to personalize this, which is a great part of this. That's another part of moving things to the edge, is the fact that, my heart rhythm is different than your heart rhythm.
Exactly.
So using the same model for both doesn't make sense.
Yep.
But these devices are going to learn and know you.
Yeah. And in fact, that's a very, very important point, because today we operate on a lot of healthcare through statistical ranges, which are not necessarily the same thing that you see for each person. I mean, I personally have been a party to a challenge that comes with it, where certain statistical ranges for my wife didn't quite work out, because what was normal for her was considered low on the other ranges, or vice versa. What was considered high for her was considered normal in the statistical ranges, which is not a great way to guess on what kind of treatment you need. So yes, I think there's the extremely positive side of what can come out of this, but also we tend to find companies are getting there. They're seeing that. What's holding it back from that next step of utilizing all of that? What are the technical challenges, and what do you see helping them solve it?
Actually, I'll be funny with you, because I don't think we're having technical limitations. I don't think the technology holds us back anymore. I think we have all those pieces of the puzzle, and they're not perfect, but each generation, they get better and better and better. I think if anything else, the industry or perception or just time is holding us back because this is advancing so quickly. And sometimes you run into organizations that don't want to change, don't want to look at new ways of doing things. But when you look at the startups, especially here at CES, you see how fast technology is really going. So as long as regulators, as long as certifications, as long as laws that are misused like HIPAA aren't kept in the way, the technology is going to be going at light speed.
Great. So in terms of that, if you were to look for solutions at the edge, okay, what do you see are the key, let's say, characteristics or features of that? Right? Do you see specialized models and specialized hardware for each? Do you see for it to scale needing more platforms that are scalable and versatile? Is the software building a reasonable middleware or ecosystem that can help jumpstart a broad proliferation?
I think what we do is we start with those basic models and then we learn on top of those models. And I think that's the part that we're kind of learning how to do right now. How do we take that, we take a big model, we optimize it down to a smaller model, and then we have to learn and personalize it for each application, for each person. I mean, it's not to say that you ship out a device with a different model for each person. It comes with that model, but it learns quickly over time. And that's all feasible, with the sensors we have, with the resources we have, that retraining for each model, for each person, for each user, for each application is feasible. A lot of it's still going to require cloud resources. So we're very much in a hybrid computing environment, but that's never going to change. Effectively using the cloud resources, effectively using the on-device resources, that's how we make everything more efficient and more cost-effective.
And speaking of which, right, let's bring it down towards BrainChip and Neuromorphic. Now, Neuromorphic is a path to a destination. If we're moving towards the edge, how does Neuromorphic technology help?
Well, a key thing about neuromorphic technology is it tries to mimic the human brain. So it's part of that relearning or using multiple models. And those are two key aspects of a lot of these devices. Even simple keyword detection requires several different neural network models to effectively do it. So being able to handle multiple models simultaneously or in series is a critical part of it. Neuromorphic enables a lot of that, but also that, learning over time is a critical part of that. And so Neuromorphic is one of those solutions that's really going to get us where we need to be with that personalized AI experience.
I think that's, again, very much in line with how we've been thinking about it. And right now, while we're showing, one shot, few shot learning, a lot of what we're doing with the second generation starts being able to learn with lesser data and go towards a much more continuous learning environment.
And it's not, and I agree with you, you're showing the one shot, two shot learning, but really it's, when you think of it in a broader perspective in some of these applications, it's one shot, two shot relearning or customization of that model.
And in fact, part of what we're probably underselling, we're thinking about it from one shot, two shot, but what we've seen is actually it's learning more than what we think it's learning.
Exactly.
And in fact, as we've seen our second generation evolve, we are seeing more of that. So let's bring it down to what you've seen so far, which is still, majority of it is still based on our first generation technology. We tried to show the versatility of BrainChip solutions across industrial, automotive, various types of sensors, etc. What is your take on what you saw so far?
Well, I think especially for the demos you have here, being able to do it with a microcontroller. So being able to do it in a very power efficient solution, small form factor solution is really key. And being able to customize those models very quickly, very easily. Although I'm questioning it a little bit, because when we did the, identify a person, it actually identified me as a person. So I'm questioning the validity of the data here. But no, other than that, I was very impressed with the range detection, with using the IR, the infrared sensor, and everything else. I think this is and the ability of all these. I mean, you're showing a number of different types of neural network models, and that's critical, because once again, we're going to see a lot of models running simultaneously and running together. So it's impressive, being able to do this, low power, small form factor, very good response time, is very impressive.
Cool, thanks. And I think what we're seeing is learning from what we've done in the first generation. How can we reduce BOM costs in the second generation? How can we make it learn faster and closer? Let me ask you this, right? We talked a while ago about Gen AI at the edge, right? And part of what we've been demonstrating or discussing is with the second generation, with the temporal event-based neural nets that we talked about, we can start really affecting some of the model size over and above what models themselves do to shrink. Is that a great starting point for when you start thinking about moving generative solutions to the edge?
Oh, absolutely. I mean, it's a two-step process. One is reducing the size of the neural network model, and the second part is what we've talked about, customizing the neural network model. So, I mean, that is a critical step.
Great. Well, Jim, thanks for your time. And I'm sure we'll talk again towards the end of the show. Have fun at CES.
Thank you very much.